Take a moment, pause the video, and copy down the 4 questions. Okay, so we're going to continue in 7.1, which is inverse trig. And now we're focusing on composite. Composite is a 2-step question. We start by finding the answer to what's on the inside of the parentheses. And when we find our answer, then I'm going to find the inverse of that answer. All right, so let's go ahead. Let me zoom in a little bit. So we're starting off by answering this question. What is the sine of pi over 2? The sine of pi over 2 is 1. So now that we know that, now that's what's on the inside of the parentheses. So now we're going to take the inverse cosine of 1. So remember, inverse cosine is between 0 and pi. So looking at your unit circle, top half, what angle has a cosine of positive 1? And that would be 0. Again, every answer will be in radians, no degree answers. All right, let's go ahead and look at the bottom question. Okay, so we're going to start off by finding the answer. What is the cosine of 3 pi over 2? That's the x value. And that is 0. So now we have to figure out, where is tangent 0? Well, we know that tangent is y divided by x, and at 0 degrees, y is 0 and x is 1. So the answer would be 0. That is the angle where tangent has a value of 0. Okay, looking here, take a moment. Feel free to pause the video. Figure out the cosine of 5 pi over 6. Cosine is x. So the cosine of 5 pi over 6 is negative root 3 over 2. Now I'm going to take the inverse sine of negative root 3 over 2. So when we look at our unit circle, remember that sine can only be in quadrants 1 and 4. And if we have an answer in quadrant 4, we do not use these answers. These are a big no-no. We have to reflect it across the x-axis and make it negative. So this first angle would be actually a negative pi over 6. Here would be a negative pi over 4. And this would be a negative pi over 3. And if we get down here, this would be a negative pi over 2. Okay, so so we figured out, I'm looking for the inverse sine of negative root 3 over 2. Okay, so looking here, sine is negative root 3 over 2 at negative pi over 3. So that would be my final answer. So we have a 2-step question. All right, now we're going to look at this example here, where we have the tangent of pi over 4. Well, that's one of our favorites because that's our 45, 45, 90. And we know that when we divide any two things that are the same, you're going to get 1. So the tangent of pi over 4 is positive 1. Okay, zoom it back out. So what this is asking me, because this is +1, I'm going to find the inverse cosine of 1. So going back to the top half, where is cosine 1? And cosine is in the top half. This is where I'm looking when I'm evaluating an inverse cosine. So I'm looking at the top half. So where is cosine 1? And I kind of erased the answer, but cosine is 1 right here. So my answer is 0. So these are my final answers. We had a lot of zeros. Okay. Now let's move forward to a few more inverse questions. We're going to do it the exact same way. Okay, so there's a couple ways to do this. Whenever it is the same, go ahead, pause the video so you can copy it down. But when we have the same trig function, notice how here it is just a cosine and an inverse cosine. What we're doing is making sure that the answer is within my restriction. So cosine, we have to have answers between 0 and pi over 2 is actually within that restriction. So that would be my answer. Okay. When I look here, again, these are the same. We have the same trig ratio. We have to say, well, it's 5 pi over 4 within my restriction of negative pi over 2 and positive pi over 2. So let's look at the unit circle. Okay, so 5 pi over 4. Remember, for inverse sine, I'm looking here. But 5 pi over 4 is over here. Okay, that's not in my range, okay? So what I have to do is figure out, and because it's a negative, I know I'm definitely going to be in quadrant 4. Which one of these angles would have the same value? Would have the same sine value as 5 pi over 4. Which one of these angles has the same sine value as 5 pi over 4? And that would be negative pi over 4. Remember, we cannot use these numbers. We're going to take these away. Don't use them. So it would be a negative pi over 4. And then we have the, we have the, I'm going to skip over this one temporarily and come back to it. But here, these are the same. Okay, so good for us. They cancel. Or they don't cancel, but, well, they do essentially cancel. And I'm left with 11 pi over 6. But remember, cosine, when we're talking about an inverse cosine, we're only looking in the top half. So this is where I'm looking at for inverse cosine. 11 pi over 6, that's over here, okay? So what angle has the same, because we're talking about cosine now, what angle has the same cosine as 11 pi over 6? So the cosine of 11 pi over 6 is a positive root 3 over 2. So that means that my answer would be positive pi over 6. Okay, so now let's look at this tangent. This is actually asking the question backwards. If we look at these three, we started off with an angle, and we had to go back and find the answer. Here, we start off with an answer. Okay, so what we have to do is figure out which angle has a tangent of negative root 3. And again, notice that on the inside, we're starting with an inverse. And because I'm starting off with an inverse, I'm restricted to only these two quadrants. So, looking here, because it's negative, I know I'm in quadrant 4. So, a couple of these we can cross out. We know it's not these two. We also know it's not that, because that would be a -1. So we're actually in between two answers. We got a 50-50 shot. We have -pi/6 and -pi/3. So tangent is y divided by x. And the answer that we'll give you after you do your keep, change, flip is -pi/3. So what this is saying is, so we got -pi/3. And then we have the tangent of -pi/3. And we get the same answer, -pi/3. So, similarly, when we are looking at the same, okay, we're looking really at the range, okay? And on the next slide, you'll have your range. But tangent, you can take a tangent or a cotangent of any number, because that trig function has a range of all real numbers. So when you're doing this for a tangent, it's always going to end up with the answer in between. Now for sine and cosine, that's a little different. We have to make sure they're asking us for a angle that has a value between 1 and -1 and 1. So that's a little different. All right, take a moment. And this is just, again, showing the restrictions. Feel free to copy it down if you need to. But pause the video, copy it down. But when we are looking at the number, whenever we have an inverse, we start with an inverse. See, we always start inside. Okay? If it's a cosine, we can only use numbers between -1 and 1, and sine has to be between -1 and 1. Tangent, however, could be any number. So take a moment, pause the video, copy down the 4 questions. Okay, so looking at our unit circle, what angle, so I have sine. Okay, what angle in quadrants 1 and 2 only in quadrant 1 and 2, what angle has a cosine? Because remember, I'm starting off with cosine. What angle has a cosine of 1? Looking only in quadrants 1 and 2, the angle that has a cosine of +1 is 1. Is 0. Sorry. The angle that has a cosine of +1 is 0. So I'm going to put a 0 right here. Now I'm going to figure out what is the sine of 0. So looking at your unit circle, find 0. Sine is the y value, and that final answer would be 0. Okay. Let's look here. We have -√3/2. Pause the video and find the angle that has a sine of -√3/2. So we know we're in quadrant 4, and the angle that has a sine value of -√3/2 is 5π/3, but that's not in the range. So instead of writing 5π/3, our answer would be -π/3. Okay. What angle has a tangent of 0? Tangent is y divided by x. So if you look at 0 degrees, you have 0 divided by 1, and 0 divided by 1 is 0. Okay. So what's on the inside of my parentheses changes to a 0. And then I'm going to take the sign of 0. The sign of 0 is 0. And that would be your answer. Okay. This does not exist. Okay. Remember, sine has to fall. Sine and cosine have to be between -1 and 1. This is too big of a number. So that is actually undefined. And on our unit circle, remember the graph of cosine did not have any asymptotes. So what angle has a cosine that is undefined? No angle. That is D and E. There we do not have an angle on our unit circle that has a cosine that is undefined. Going back to the graph of cosine. Cosine did not have any asymptotes. It was continuous. Okay. Go ahead, copy down these 6 questions. Pause the video. Copy down all 6, and then we will talk about it together. Okay, so these two cancel each other out. So remember, cosine is between 0 and pi. Is pi over 12 between 0 and pi? Yes. Because this is actually within the range that I'm looking for, my answer is just pi over 12. As long as that number, okay, because these are all the same, as long as the number falls within my range, the restriction, then that answer is going to be the same. So here, these cancel out. Is 0.4 in between -1 and 1? Yes, it is. So the cosine of the inverse cosine of 0.4 is 0.4. Okay, these cancel out. But remember, sine does not go higher than 1, so this does not exist, undefined. Tangent, however, you can take the tangent of any number. Tangent has a range, let me go back here, of all real numbers. So -infinity to infinity. So we can actually find the inverse tangent of 4. And because these are the same, we're just canceling them out. And my answer is 4. So we are checking to make sure that this answer right here, this number, because it's the same, we're making sure it falls within the range. Let me go back again. This is what I mean here. Has to fall between these different restrictions. All right, tangent. Okay, so again, tangent is between -pi over 2 and +pi over 2. Tangent is between -pi over 2, +pi over 2. But we can't use -pi over 2 or +pi over 2. So the first thing we're going to do is look at our unit circle. And we're going to find -2 pi over 3. So that's a little tricky. So what we're going to need to do before we can finish this is figure out what angle on the unit circle is equal to -2 pi over 3. So I'm going to add 2 pi to it. And I get 4 pi over 3. So this question right here can actually be rewritten as the inverse tangent of the tangent of 4 pi over 3. Okay? Okay. So we got that part. Now, 4 pi over 3 is not within our range. 4 pi over 3 is not within our range. Okay? So, when I look at the unit circle and I find the tangent of 4 pi over 3, you see, I think this one, let me go back a little bit so we have a picture of a unit circle. So when I'm looking at my unit circle and I'm looking for the tangent of 4 pi over 3, that means I'm taking negative root 3 over 2 divided by negative 1/2. Keep, change, flip it. And negative root 3 over 2 times negative 2 over 1. This cancels, and my answer ends up being a positive root 3. So what I'm looking at is the angle, because it's positive. Keep in mind it's positive. Okay, tangent is positive. Okay, so that means that the inverse that I'm looking for is going to be in quadrant 1, because this is where tangent is also positive. So looking here, what angle has a tangent of positive root 3? And the one thing I like, there's a lot of things I like about the unit circle, but it's all a reflection. They're all connected. So when I'm looking here, I can actually trace this all the way up. That is my answer. My answer would be positive pi over 3. Let me get back to that slide. So my final answer is positive pi over 3. So that we had to do a lot of steps in between. Hold on, let me fix that. We had to do a lot of steps to get there. First, we had to convert that negative 2 pi over 3 to an angle on our unit circle. And then we had to find the tangent with keep, change, flip. And then we had to reflect the answer. So there was a lot. But our final answer would be positive pi over 3. All right, our last one. This is very weird, right? We're like, what is that? 3 over 17. Well, 3 divided by 17 is definitely less or greater than negative 1. Okay, so between negative 1 and 1, if you could use a calculator, which you cannot, if you were to divide 3 by 17, you would actually get a decimal that is within my range of negative 1 and 1. As long as, so the trick here, if you haven't quite figured it out, when it's in radians, as long as the numerator is less than, the number in the numerator is less than the number in your denominator, it's going to work. So looking here, this had a 1. Well, that 1 is definitely less than 12, so that worked. This one has a 3. Well, 3 is definitely less than 17, so that's going to work. And the reason why we don't have to change it, for the last one, I had to reflect it, because if this was actually in our range of negative pi over 2 and positive pi over 2, that would have been my answer. Okay, but that number, that angle, when you look at the unit circle, negative 2 pi over 3, or in this case, positive 4 pi over 3, that is actually in quadrant 3. So we can't use quadrant 3 for an inverse tangent. So I had to go up to quadrant 1, because that is the other place where tangent is positive. All right, so for this last question, because these are the same, because the numerator is less than 17, I know my answer is going to be something less than or something greater than negative 1. So my answer is negative 3 pi over 17. Okay, remember your notes have to be handwritten in your handwriting, and you have to upload it to Canvas. Do not email them to me, and we will continue review on Wednesday. Have a great day.